Okay, we're back here for part 3. And the last thing, okay, we're going to look at some word problems here. At least, at most. When you're dealing with word problems or when you get confused, when I get confused, I try to think of examples that are easy for me to visualize. So directions represent each expression algebraically and graphically. Mr. Covell has less than $10. So less than $10. Here's 0. Here's 10. I like to think of examples with money because that's something that we use quite often. And so it might be easier for us to relate to. If I have less than 10, then that means I could have 9, I could have 8, 7, and so on. Less than $10, first of all, is open, and then everything to the left. So I could say C is less than 10. C for Covell. Less than 10. Now if we say more than, I have more than $10 or greater than $10. Think of numbers that would make that true. If I have more than $10, I could have 11. I could have 15. I could have 200. Notice that those are all numbers that are greater than 10. So, open circle, because it's not equal to 10. I have more than that, greater than that, and we graph that to the right. So the inequality would be C greater than 10. If I have at least $10, at least, so that means I could have 10 or more. That's what that means, that at the lowest amount I have is 10. So I could have 10, I could have 11, I could have 15, I could have 200. So 0, 10. 10 or more means I could have 10, but I could also have more than that. So C is greater than or equal to 10. So notice, at least is the same as greater than or equal to. Now the last one, at most $10. At most, that means at the highest. The most I have is 10. That means I have less than or equal to 10. So 0, 10. Now I can have 10, so I close this, but less than or equal to goes to the left. So we've got to be able to take the vocabulary and change that into the symbols, the inequality symbols, and change it into the graphs. So let's take number 12. We'll take a word problem here. Mr. Jones has $6 to spend. A sundae costs $3.25 plus 65 cents, 0.65 per topping. Write and solve an inequality to find how many toppings he can order. All right, now the first thing I'm going to do here is I'm going to say I'll use T equal the number of toppings. This is called defining my variable. We did this with word problems when we were looking at that back in chapter 2. So we're going to say that T, we pick a variable to represent the number of toppings, which is what we want. Write and solve an inequality to find how many toppings he can order. Well, we know he has $6 total. That's the most he has. He can't spend more than 6. To buy the sundae, he has to pay $3.25. So I'm going to say 3.25 plus 0.65 per topping. Well, that's 0.65. The number of toppings is T. Each topping costs 65 cents. So if I had 3 toppings, it would be 3 times that. If I had 5 toppings, it would be 5 times that. Now, he can spend, at the most, $6. At the most is actually less than or equal to, because that number, that $6, is the highest that it can go. So we're going to write that as less than or equal to 6. And now we can go to work and solve it. So we'll go minus 3.25. So we get 0.65 t is less than or equal to, that would be 2.75. And then our last move here is to divide by 0.65. Let's see if this will work out. I'm going to take a calculator here. 2.75 divided by 0.65 equals, 55/13, which is a decimal, is 4.23. Oh, wow, that's a big repeating decimal. Okay, so approximately 4.2. I will approximate. T is less than or equal to about 4.2. Now you can't have 0.2 toppings. So how many toppings can he order? Well, we can't go more than 4. So he can order 4 toppings. Because, again, you can't have a decimal number of toppings, a fraction number of toppings. If we try to go 5, he's going to pay too much money. He doesn't have enough money for that. If I substitute 5 here, if I do 3.25 plus 0.65 times 5 toppings, that's $6.50, but that's too much money. He doesn't have that. So in this case, I actually am going to round down to 4 toppings. That's what he can order. So when you're doing these word problems, you have to think about, when you answer it, if your answer makes sense. You have to think about, in the context of the problem, I am not going to write a decimal here for that. Now, last one, number 13. At the store, Covell's Calculators, that's a great store, Mark makes $260 per week plus a 15% commission of his total sales. Everything he sells, he makes 15% of that value. So that's extra money that he earns. If Mark wants to make at least $500 for 1 week, what is the fewest amount of sales that he must make? He wants to make at least $500. At least is greater than or equal to. So we want to make at least $500. That's going to be the right side of the inequality. So what's the fewest amount of sales that he must make? So let's say let S equal the number of sales. I will try to write this very clearly so that it doesn't look like a 5. Now his money, he makes $260 per week no matter what. So we'll start with 260, but he can add money by selling calculators or selling the product. Now 15% is 0.15 as a decimal. If you make a fraction or a decimal of something, that means you multiply. Now we're multiplying by, it's the percent of sales, percent of his total sales. So that's 0.15 times S. That's our equation, or our inequality. $260 plus 15% of all his sales. So let's go ahead and subtract 260, because now we can solve this. 0.15S is greater than or equal to 240. And then this is 0.15 times S. We're going to divide by 0.15. And we'll definitely use the calculator here. 240 divided by 0.15 equals 1,600. So we have S greater than or equal to 1,600. Now, what does this represent? S is the number of sales, or the amount of sales that he has to make. So the money that he has to sell, or the product he has to sell, has to be greater than or equal to $1,600 so that he can make a total of $500 in 1 week, at least 500. Now, if he sells more, he makes more, but at the very minimum, he has to make $1,600 of sales. And that is the end of the notes.